This time we're going to look at the Tooltop ET638. This would give any network guy a woody. I mean, this is a network guy's wet dream. This meter will do just about anything. It'll analyze coax, it'll analyze Ethernet, it'll analyze fiber optic, give you your dB loss, even has a built-in visual fault locator, and it has a multimeter to boot. So it'll do everything. Test transistors, diodes, capacitors, resistors, volts, up to 10 amps. This thing does it all. 4 meters in one. I think we have a winner. Today we have a network cable tester with a visual fault locator. Oh, well, this tests fiber optics. It looks like it might. Cool. Might be able to use this thing at work. Let's check this one out. Look at all the gadgets you get in this pack. Let's check it out. So let's take a look at what's in the box. First we have a test clip. We have Ethernet cable and a breakout cable. We have a USB-C charge cable. We have the meter and we have the receiver. And what does this do? This opens up. Oh, that's just where the battery, I guess, lives. It's got a rechargeable battery that you can replace. Just a user replaceable battery in here, held in place with a piece of foam. Presumably you could put a higher capacity battery in there if you wished. And the meter itself, it says please tear this off before being used. The length interface is only a length measurement interface. When this function is enabled, the other end of the network cable cannot be connected to any device such as a computer, switch, PoE, or other power device. Otherwise, the product will be burned. What, this or the other product? Probably the other product. So, yeah, you don't have, if you're measuring this is for measuring the length of the cable, and you can't have anything connected on the other end because this is going to send a high voltage down there for measurement. So there's a warning sticker there to warn you before you can even utilize that feature, that you have to remove or disconnect anything on the other end. Optical power meter and a VFL. So optical power meter, I can actually demonstrate this, I think, here. I should be able to demonstrate this here. I do have fiber optics here, so I could plug my fiber coming in into the optical power meter, and this will register the power. Actually, I could use this thing at work. I have an Expo, but I could certainly use this at work for optical power testing. Let's just turn this thing on first of all and see if it turns on. I might have to charge it first. I probably will have to charge it first. Got a visual fault locator, so this one's going to generate, it's going to have a laser, it's going to generate a red light that would be fired down the laser back to the other side. Why won't it turn on? Probably because I have to charge it first, so maybe I will have to do that before I can finish this. So let's just get this thing charged up. Charge up the batteries on both the meter and on this. While I'm waiting for it to charge, let's take a look at the specifications. So it says here that it can measure cables up to 600 meters in length, and the red laser is good for optical fiber transmission distance of 10 kilometers. So in other words, optical fibers up to 10 kilometers, you should be able to see that the red laser here for the visual fault locator. So here is the connectors on the side on both devices. So here's the red laser interface, charging port, and optical power interface. So when you're testing what level is coming in from, say, the OLT on the other end, it will display here. And when you're going to test the laser out, when you're looking for visual fault, you're going to plug your fiber into this one. You've got a length interface is over here. display our flash interface, keypad, jack input, basic input for your digital inputs here, and PoE test interface and test scanning QC for an ID interface for your network. So network connectors on the right side. This is your power over Ethernet interface test, and this one here is for testing and scanning, quality checking, and ID interface, so you can ID which cable it is. And what these are for is, that's what these are for. So for example, if you've got a whole bunch of network cables running throughout your house and you don't know where they go, you can go into each room of the house, for example, and plug each one of these in to a Ethernet run, and then when you're sitting back at the main panel, you can plug them into here and it will tell you which one it is. This was remote number 7, remote number 6, etc. Sure beats the hell out of putting a tone on in one room and then running back and looking for the tone. That's the old way of doing it, right? You put your tone on one side, and then you go back with your tone wand and you go and look for the tone. And, oh, there's that cable. This way you can just do 7 of them at once and then come back and just plug into here, and each one you plug in will be identified as to which cable it is. If it's a power over interface, you're going to use that one. And on this side, that's probably why they had that tape on there in case you're not going to use it, but this is one for measuring the length. Flash interface, what that's for is if you've got a switch, right? If you've got a network switch and you've got cables plugged into your network switch and you don't know which port you're on, you can plug your cable in here. And you can plug the other side into your LAN port that's plugged into the switch where you don't know where it is, and it will cause the light to blink on and off on the switch to tell you which. So basically what it's doing is it's providing a connection and then a disconnection. It'd be the same as someone standing there and plugging it into the computer and unplugging it. Plug it in, unplug it, so that the light on the switch will blink on and off. I should be able to demonstrate this. I'll just grab an old modem or something, or an old switch, and we can plug this in and show what it does. So I'll try to go over all these features of what this unit actually does. But that's what the flash interface is for. Length interface is for plugging it into a cable that is unterminated on the other end. That's important, because if you've got it plugged into a computer or anything else, you're going to cause a problem on the computer, because this is going to fire a voltage down there for checking the length. It's basically doing TDR, could damage the equipment. So that's what that sticker was for. That is for an open cable only and nothing else. And on the other side, I say that's this side. And on the other side, it's for testing and scanning and a PoE interface test. That's what those do. And of course, for your optical testing here and for your current and voltage and ohm measurement. So this is all in one. This operates as a meter and a network tester. We've also got this one, which is it's a receiver, non-contact voltage measurement, and well, let's see what does it say here. It's got a light on, scanning area, sense area, scan select, non-contact voltage selection, sensitivity adjustment, and light. Press 2 seconds to turn the light on and off, and scan verification. And RJ45 port on the bottom of this as well. I'm going to mark, or have marked, my meter so that I know which one's which. My battery's not fully charged yet, but I figured I would just turn it on and just see what it does. So here's the interface, and of course it tells you, I wrote it down here, but I didn't really need to. If I select length, it tells you do not connect any device to the end of the tested cable, otherwise it will be burned, and it tells you which port to use. It tells you it's that port. So I marked it, but I didn't need to. If I get out of here, if I go to the next one down here would be, where are we here? Well, wire map. Breaker short. So on this case, 1 and 3 are connected together, and 4 and 7. On this particular, that's going through this. On this, you would normally, I believe, just short the pairs together, and it would tell you which pairs were shorted. Next, we have scan for cable ID. That's what that does. This is going to go off when you're right next to a cable, right? But what you can do is you can plug your cable into the bottom here when you're in test mode, and that will beep, right? And it will tell you there's a light that comes on here, right? Right now, it'll beep, and that light will flash through induction. But for actually testing a cable to make sure that you're on actually the right cable, you can plug it in here, and this light will light up to tell you that you're plugged into an RJ45 plug. Next is the QC test. This tests crimp-on connections to determine if any of them are bad. That's optical power meter. We'll test that in a minute. I'll have to go inside to do that. Visual fault locator. Turn that on, and it will tells me which port it's using. It's this one here, and if we open this up, you'll see that it's got an extremely bright red laser in there. That is, wow, that is bright. Like, that is 10 times brighter than what I use at work for testing, for tracking down. I can see that on the wall. This thing is just ridiculous how bright this thing is. Check it out. That is pretty bright. That'll go down the fiber, no problem whatsoever. Wow, I'll be taking this to work. ID, that's the one I was looking for, ID. So now we plug in our cable, and this will tell me which one I'm on here. I'm ID7. So you plug these into all of your outlets throughout your house, for example, or your business. Plug one into each one, and then go back and test them, and it will tell you which cable you're plugged into. I'm in number 7 now, and the next one I'm checking was number 2. It'll light up ID number 2. Simple as that. That's all that is. Pretty simple. Basic stuff. But very useful when you're wiring a network and you need to know which one's which. Next one down on the list is a digital multimeter. A multimeter, get DC voltage, AC voltage, and it tells you which ones to use, right? It tells you to use these two. Milliamps, going to use these two, and amps. Ohms, again, these two. Diode test, continuity test, capacitance test, and frequency in hertz. This is fused, by the way. There's a fuse inside here, obviously, that will pop if you put more than 10 amps through it, so don't put 10 amps through it. That's the multimeter. We'll go through that momentarily. What is this one? Account. This is where you can calculate out how much to charge a customer. You plug in your cable length here, and it tells you what the length of the cable is, and you can put in what you charge per meter, dollars per meter, and it'll tell you the length of the cable and how much to charge the customer, and then you can save it. That way, if you're measuring your, for example, if you're wiring a house, we'll use that as an example. You're wiring a house or a building, and you're the contractor, and at the end of the day, you have to account for how much cable you used. You can go back after the fact if you haven't been keeping track, which a lot of the guys don't. Sure, if you've got a box and it's marked how many meters of cable or how many feet of cable you used. Cables are usually marked, but most of the time, contractors do not just use one box. They're running multiple boxes, and they're running them all at once. They're pulling them in from different rooms, and they might have 5 boxes of wire being pulled at once by the crew. So this allows you to go back after the fact and measure each run and say this run is this many meters, this run is this many meters. You can add them all up. You can save it into the meter and then recall it, I guess, later on, and then use that for calculating. Put in your cost and use that to calculate. That is what that is for. Setup is where you'll be able to set things up, like set up the language, brightness, auto power off, sound on or off, LED light on. Oh, that's this one down here. There. That's what that is. It tells you your LED and the beep off or on. That's all that is. Okay. And that is the basic operation. We'll go through this little device as well that comes with it. This is your non-contact. Well, we know it scans. We already saw that on scan. That's for scanning out your cables and toning things out. We turn it on. scan will pick up your tone. The other function, of course, is non-contact voltage. And now it beeps. Neutral side, hot side. Neutral side and ground, of course, don't have any power on them. But the hot side certainly does. If I turn the sensitivity up full, it'll beep even without getting that close to the wire. Sensitivity down low is for testing obviously higher voltages. It'll still detect it when I get the wire right up, or get the probe right up against the wire. Normally you'll be using like the middle. If you remember the scan function, you can also use this other test lead that came with it. This is for testing cables that are non-network cables. So you can plug this in, and if you're, say, testing coaxial cable or any other type of non-network cable, you would connect the alligator clips up to the cable you are testing, and it'll work exactly the same way. In the scan function, it will show you which wire is which. So that's good if you're testing coax lines. If you're looking to see where coax lines run, you can use this feature and just clip this on to the coax. That's what that feature is for. Same thing. And it sends out a signal that is identified by the scan on this. I did go over this, the QC mode here, which they call the crystal plug crimping. That is to determine whether your cable has been crimped properly. And to test that, you have to wait for the self-test to complete. So if we get out of here, if I go into this, it'll do the self-test. It's calibrating the setup. Okay, now it's ready. You've got all these X's. You take your patch cable, and it can be anything. I'm going to use this one here just as a result for testing, but you can use any patch cable. You do not have anything on the other end. You just plug it in, and it will test all the pairs. And what it's doing is it's doing a ringback test to make sure that there's no loose connections. Any of these that have failed or are not crimped properly, it will show as a failure on the display. It'll tell you which pair, which pin is not properly crimped. Kind of a useful test for testing out your network cables and so forth, because we've all had situations. I could use this at work because I quite often run into I haven't done the wiring here. It's a new home that's been built and the electrician has crimped on connectors, and we get trouble calls. TV is pixelating, things aren't working properly, the computer's running slow, we're getting errors. Go up there, plug it in, open cable, and look to see whether it's bad. You don't need any other test equipment, just plug it in, and that is it. It's good to go. Okay, I'm now in my my equipment closet with the switch and everything. We're going to test the flash feature, so I'm going to plug this in to a spare port on my switch, and we're going to watch and see what it does. So I've just plugged an Ethernet cable into my switch. You can see the light is out. Other devices on there are blinking away because the switch is loaded and it's operational. We're going to expect to see that light start to blink as soon as I plug in the other end to the tester. And now you can see it's making the light distinctly blink on and off. That's telling me which port I'm plugged into. In this case, I've plugged it into my PoE switch on port number 2, and you can see that port number 2 is now blinking to indicate that it's in the test mode. Now the only thing that's got PoE on here is port number 8. So next we're going to test the PoE test, and the PoE light should light up on port number 2, and it should give me the voltage for the power over Ethernet, because this switch is only feeding one camera over with power over Ethernet. The rest of them don't use it. So we go over to PoE, select PoE, and it will turn it on. Well, I got to switch it over to the other side, to the PoE port that's flashing. And now we can see that there's 50 volts being fed out from the PoE switch, and it's telling me it's on pins 1 and 2. 1 and 2 have got 50 volts on them, the others don't. Pins 4, 3, and 6 do not. And it's because PoE can use 1, 2, or 3 and 6. It depends on the type of cable. If you have a cable that's crossed over, you can have a crossover cable would use pin 3 and 6 for the power over Ethernet. And the light will be lit up on the switch itself. Which, as you can see, port number 2 has the PoE light lit, as well as port number 8, which is the one that is feeding my camera. This time I check the optical power. This is my fiber optic is plugged in here for my ONT. I know that I'm on, well, this gives me my power, 29.1 microwatts, minus 15 dB. I should be able to step through, how do I step through the wavelengths? Here's the different wavelengths. This is 980 nanometers. I'm on 1550 is what we're on here. So I can step through 850 nanometers, it's minus 15 dB. This gives me the actual power that's being received for the different frequency bands. I'm on, normally we measure 1490 for GPON. I'm on XGS, so this is 1550 nanometers. 51 microwatts is what's being received. Plus 2.44 dB, and the received is minus 15.05. I have a very strong signal here, but that is very useful for testing out the received optical signal strength. We're going to check the cable length. This is a 10-foot cable that I've got here, and I've got it in feet. You can switch it from feet to meters. I've got it set for feet. Let's plug it in. Just an empty cable, 10 feet long. At least that's what it said on the package. And this is saying it's 9.8 feet. But there it is in meters, 3 meters. And that would be what this cable is. This is a 3-meter cable. We can also measure coaxial cable, for example. You cycle through the type of cable by pressing the up arrow, so it can measure a RJ45 that's only got 2 pairs in it. It can measure an RJ45 with 4 pairs or 8 conductors. It can measure a telephone cable, which has just got pairs 4 and 5 connected to it. And of course, BNC or coaxial type cable. We're going to use the adapter that came with it. This is set up for pins 1 and 2. If we look at the, well, there's other pins hooked up, but it's measuring it from pins 1 and 2. If we plug this in, this is a 30-foot piece of cable that I've got here, or roughly 30 feet. We plug in the adapter and we will connect, and I've got it in feet. Connect it here and connect the other wire to there, and it's showing me 29.2 feet, which is pretty close because I believe it's about 30 feet long, this cable. For those curious as to what is actually sent out down the cable to measure the length, well, that's what the signal looks like. That's just frozen on my digital scope. It looks to be 1.71 volts, so it's not high voltage. And it looks to be a frequency of about 83 hertz. Looking at the scope here, if I freeze it, this is what it looks like. That's what the scope is capturing. If I slow down the time base, you'll see. And we can look at it in detail. Here's my snapshot in time. But it's just a 1.73 volt peak. You got a negative going pulse and a positive going pulse. And what it does is it measures what comes back. So it sends a signal out, it'll do a negative and a positive pulse, and then it's listening. And this is when it's measuring when it's coming back. And it's doing that at 83.72 hertz is the frequency that is doing it. So the longer the cable, so when it detects the signal coming back, there's nothing coming back now because it's on the scope probe and it's showing it as 0 feet. But when it's measuring the cable, a reflection will come back, and that reflection, depending on where it is in here, will determine how far it is away. I'm sure at this state of the game, I've probably bored you guys to death on the network testing capability of the meter, but I wanted to spend a little bit of time on that. And I say even the optical testing. Not that most consumers are going to have to deal with any type of optical testing. For anybody in the telecom business or anybody in networking business where you're dealing with both Ethernet and fiber optic, this feature is invaluable. And for me at my day job, for example, I have a VFL, visual fault locator, ruby red we call them, which just shoots a red laser down. We use it for testing or for tracking fiber. And I have a separate optical power meter that I use for checking my levels. So if I were to take this to work, well, I could have everything all in one. I could have my LAN tester, my length tester, my power over Ethernet, even though we don't use that. I would use this feature for sure. And I could use the VFL and the optical power meter at work for my day job if I so desired to take this with me, which I just might put it in my tool bag. I've spent the time going over this particular feature just because that's the specialty portion of this meter. We can go down to the digital multimeter now, and we'll select DMM, and I'll just do some voltage and resistance and capacitance measurements using the probes that came with it. We'll go over that quickly though. That's probably what most people would use these if they bought one of these meters for it. But again, if you don't need to have these features, then most people would just opt for a regular meter. But if you need these features, I think it's a good option to have that. Someone who's looking to buy one of these meters is buying it because it's got these features, the optical testing and the LAN testing. That is the reason why somebody would buy one of these meters over just a basic DMM. And that's why I've spent more time going over those features, just because that's what makes this meter a little more unique than the run-of-the-mill meter. So let's plug in the test leads. I've got my power supply set for 9.1 volts, and we'll just do some voltage measurements, and we'll do current measurements and the other basic functions that the meter will do. One thing that's nice is the display is 5 digits. So it's telling me my voltage is 9.23 volts. Well, it could be. Let's compare it to the reference, the Fluke. So it's telling me it's 9.2, and the Fluke says 9.23. So that is dead on accurate. Let's turn the voltage up. Let's take it up to full power, 32.1. Any questions? I'll dial it down to 5 volts, 5.09. Let's check the AC voltage. So I'll check it first with the Fluke. I'm going to check the line voltage coming in here on my little extension cord that I've got sitting at the side of the bench with the little built-in neon light, so we know that it's live. $121.6 volts, and we'll switch this down to AC voltage. $121.3. Of course, it could have changed from the time I measured it before, but that's still pretty accurate. I gotta be careful here because this is not isolated, and I could give myself a nasty jolt if I'm not really quite careful here as I jam these test leads in. So Fluke's measuring 121.7. The Tooltop meter, ET638, is measuring 121.5. So we're close. We're within a couple tenths of a volt. I think that that is accurate enough. AC voltage measuring good. We'll do some resistance measurements, and we'll test some diodes and that type of stuff, and try to finish this up because, again, it's getting a little bit long in the tooth for the basic multimeter functions. We're just going to go over that. I just grabbed a couple resistors, 820 ohms and 2K. We're going to switch this down to ohms. I've already switched the meter here. This one here is 820 ohms. So Fluke's measuring 814. 815. Looks accurate to me. This one's 2K. .9849. Fluke 1.978. It's a 2K resistor. This resistor is a little bit higher in terms of resistance. This should be about an 80K resistor, 79.5K on the Fluke, 79.3. So we're splitting hairs here. All right, first one's 47 microfarad, 250 volts. Fluke says 44.4 microfarads, 44.5 microfarads. This was measuring 111.8. That's a 100 microfarad cap. The Fluke meter says it's 112. Any questions? It says it's 900, 921. It'll settle in here in a minute, but 932, approximately 922. So it's a little bit low, but it'll go to MF, right? Not microfarad, but millifarad, I guess, MF. So 0.9, well, 1000 microfarad would be 1 MF, not a UF, but MF. So 900.9, 910, 900, so it's close to what the other one measured. Okay, that's the capacitor test. Hertz, well, that's going to measure the frequency coming down the line. If I plug this into the AC line, it will tell me that it should be 60 hertz, which it is, which is to be expected. What else can we test? Well, it has a continuity test. It's just a buzzer, right? Pretty standard. Diode test. We'll do a quick diode test on here before the battery goes dead. Just have a transistor here, and this should be an NPN, I believe. Yeah, this is NPN. 0.6 volt, 0.67 volt drop. Emitter to base. Same thing, right? And open between emitter collector. So that's diode test. Just gives you your voltage drop. So say the battery's about to die on this thing again. You can see it's right down at 0. What else have I missed on this? I have not done milliamps and amps. We'll just do that quickly. Alright, I'm going to test AC current. I've got my, if you can see, I've got my heat gun. This is going to probably draw about 6 amps. It's on low power. I got my one prong plugged in. I got another prong here. And I'll plug this in. And it's going to measure 6.1 amps. That's about right for this heat gun that's drawing the power that it's drawing. I'm not going to kick it up to high power because that'll be over 10 amps, which will pop the fuse. But 6 amps, 60 hertz AC. And it's giving you your current measurement here as to the percentage of maximum that the meter will measure. I think that's about all I can show you on the meter as far as the functions of it go. I'm going to pull this thing apart quickly just to show you guys the inside of it. Not that there's probably much to see, but inquiring minds will want to know, and you guys want to see what's inside these as much as I do. I want to see how well it's built. 4 screws hold the back on. Now those just go like that. That's what holds those in place so you don't lose your covers for the optical plugs. But the back comes off. Oh, there's the fuse, so you can replace the fuse if you pop it. 10 amp fuse right there. And there's the lithium battery that's there. And there appears to be 2 circuit boards on this. I wonder if this will pop out. I should be able to lift the board out and we can see what's on the other side. Wow, quite a bit in here. We've got 3 circuit boards, one for the display obviously. You got an interface board here, and here's the board with all the circuitry on there, and it's got a lot of stuff on here. Looks like you got a little opto isolator over here of some type. This is our VFL and power detector. It's pretty packed with with components, as you can see. I'll just get a bit of a close-up here, and then we'll throw this thing back together before I break it. So as you can see, it's fairly busy in here. Now you're expecting to see everything on one chip? Not on this one. This has got a fair bit in it, which would be expected because this meter does a lot of different things. Right? This has got a lot of different test features. It's not just your standard DMM. It's got a lot of features. And I'm going to leave it at that and throw this back together before something gets broken. Since I did have to turn it on because I didn't know when this fell out which was which, the VFL is this one. I can see the red LED lighting up down here. So this is the receiving side over here. The one that had the 3 wires is the receiving side, and this one here is the transmitting side. As can be seen, if I pop that out, there's the red laser. So that's the side that goes over here. One of the reasons I opened this up to show you guys what was inside it was to show you that the battery can be replaced. It just plugs in. It does have battery protection here, and when you're putting it back together, just set these little ball chains into their respective keepers, and that'll hold it in place for the little pins here that will line up with it, and it'll lock them in place. But I wanted to show you guys how to open it up so that if you have to change a battery, for example, or change a fuse, it's relatively easy to do on this. Some meters are a real pain when you try to open them up. They just do not want to come apart, and they don't want to go back together. And this one here, well, it goes back together pretty simple. And then just the 4 screws that hold the back on, and you're good to go. Construction-wise, the cabinet itself feels to be pretty strong. I wouldn't be dropping it off of ladders or anything, but it does feel to be a fairly robust plastic case. Anyway, that's it. I'll throw the link in the description for this one. I think this is probably a pretty useful piece of universal test gear that a lot of people will find very useful, especially if you work in the telecom field or data cabling, like structured cabling. This is the cat's ass for doing that type of work. Thanks for watching. We'll catch you in the next one. Bye for now.